Good morning, everyone. Thank you for coming. I am Ilir Belir. I'm the moderator of this session, which is innovative uses of virtual reality. We have three presentations. The first one, the presenter is not here, but I'm one of the co-authors of this study, so I'll be giving that presentation, followed by Andrew Poszich with RSNH, and then by Haowen with Oak Ridge National Laboratory. So each of us have roughly 30 minutes. So we are going to present about 20 minutes, 25 minutes or so, and then the remainder of our time will be open for questions and comments, and then we'll switch to the next presenter. So if it's time at the end, then may have some concluding remarks and so on. So without further ado, I'll move to my presentation. And I have to introduce myself. So I'm an associate professor at the University of Florida with the Department of Urban and Regional Planning, and I'm a co-director of the GeoPlan Center. That's a research center. My interests and expertise are in developing geospatial systems and interactive and immersive visualization and simulation with application in urban planning and transportation. In this study here, we have many participants. One of them is Senki Xu. She is in the audience. And the others couldn't make it, but I want to acknowledge their contribution in this work. So in here, let me start my timer. There you go. So in this study, we looked at immersive VR versus 360 view of 3D models to see if there's any difference in people's assessment of street design and the way that they look at it. Does it make any difference, right? So why is that something we want to look at? Just for to be on the same page on the terminology, we all know what VR is, full immersive digital environment, and requires a headset or goggles, right? Whereas 360, I'm just going to use the term 360, simple without anything after it, to indicate basically the viewing capability that allows you full horizontal and vertical fields of view. It does not require goggles, and you just look at it on a flat screen, just like we're looking at this now. So we know that VR and 360 are not new. They're used, started used commonly in evaluating street design. The modern software nowadays, the 3D modeling software, several of them have the capability to present the same model either in VR or in 360, right, without additional extra work. So, and we know that VR continue to get investments, you know, the whole metaverse and so on. I think I'm still seeing commercials of that on TV, and there's many players. Despite all this, you know, we are aware of some challenges or problems with VR. First of all, it requires a headset. So another piece of hardware that you gotta have to deal with the weight, wearing it, the cost, the resolution. Obviously, it's getting better, and hopefully at some day we won't think about it as something special, right? But there's also complaint of some people get dizziness, and there's potential safety concern so that you don't know the environment around you because you can't see it. And then for participatory simulation, which is sort of the topic of these sessions, it's a little harder, right? It's not that practical to have, you know, rooms full of people and get them all to wear VR. So there are just some practical limitations to it. So our question was, What difference does it make when VR versus 360 is used to evaluate people's perception of street space? Right, so I'm using the term space more generally rather than the road because we like to look at the street more broadly, right? Not just automobile, but other modes of transportation, buildings and vegetation and everything else. So how did we go about doing this to answer this question? So our method was to basically survey-based research. So we developed design scenarios, conducted a survey with selected subjects, and asked them to answer some questions to give their assessment of what they're seeing on the screen. Using, it was two-phase, using first time using VR of the same designs, and the second time using the 360. So in this presentation, we'll share with you the process, the finding, and the takeaways. The design scenarios, we looked at the transect there that gives you different zones of urban built environment, and we chose to use urban zone, urban center, and general urban. So this gives you a graphics on basically, it's common in urban planning, and nowadays DOTs are looking to start considering context classification versus functional classification, the traditional one, and I'm assuming some of you may be more familiar with it. The essence is that you don't look at the street or the road simply from the traffic perspective, but you look at it also from the land use perspective and all the users. So this is the design for the urban center. It basically has a bike lane, a parking lane. A bike lane is six-foot bike lane, on-street parking, wide sidewalk was 15 feet sidewalk with trees, street furniture. You can see that the road also has a median, 8 feet median. And you can see that there is taller buildings around, and there is also a fountain, and there is a roundabout, so we're trying to look sort of at something more special for intersection that helps to enhance the recognition and identity of the intersection or the plaza space. The other one was general urban. It essentially quite common in our cities. It's a 5-foot bike lane with 9-foot sidewalk. The vehicles, well, in this scenario, typically there is no median, and you know, you can see two-way traffic, 4-way total, number of lanes, and there is no any kind of special treatment to create some special identity or recognition for intersections. So there's not you know, features that will make those things stand out better. So how did we put this together? How did we do the 3D modeling part? So we used rule-based modeling. Some of you might be familiar with it. The essence is that instead of, you know, traditionally picking up the mouse and start modeling, building the objects and so on, you write computer code. So you write a bunch of instructions, you put those together, and then when you run them, then the code, the rule-based engine builds the model. And then you can inspect and change it's sort of parametrical design, if you will, but it's inherently built this way. So the package that we used is called City Engine. That's because we have familiarity with it, but it's GIS based, so to speak. But also, City Engine contains the complete street rules. You're all familiar with complete streets design initiatives. There is a set of rules that's available free of charge on the for complete street on City Engine. So because of all those, we chose to do the experiment with that. That gives us the opportunity to build quickly these models. If you're more interested in learning more about this, we've presented here in 2019. So when you get access to these materials, there's a link to that presentation, which is a lot more about rule-based modeling. Then what question would we ask people? So we decided to ask questions to give us an understanding how they think about these variables you have on the screen. So how do they think about the comfort? You know, how comfortable is this space for you to be there, to socialize, etc.? How safe it is to drive or to bike or to walk? Is there any place recognition features that you would remember and you separate and distinguish this place from that other place? You know, nowadays, a lot of our spaces are anonymous. It's hard to tell where you are. So it's important in urban design to establish the identity for the street space. We ask them about the density, like how dense this place feels, right? So the density is a complex concept that deals with built environment, the height of the building and the presence of or not of trees, cars, people, size of space, and so on. And finally, we ask for enclosure. Enclosure, it's basically the ratio of height of the building to the width of the street, if you want to technically measure it. But for people, it's essentially how enclosed does this space feel to you, right? Very enclosed, not enclosed. And finally, we also added a sixth measure, which is about realism. All right, so this is the only one that deals with visualization, which is basically says, how realistic is what you're looking at? How realistic does that look to you? And all these measurements were measured in a 1 to 5 Likert scale. 1 means, you know, the lowest, and the 5 is the highest. For example, when asking the participant how comfortable would they feel walking along the street, 1 means the least comfortable, right? And 5, the most comfortable. Where do we find the participants? Well, we're at the university, so there are 42 participants, mostly college students, and with a median age range of 22 to 29. Then once we built the model, got the subject, then we conducted the survey for the VR. Essentially, we were given the participant access to VR Oculus Quest 2. That's the goggles that we used. And in the reception today, we have an interactive poster presentation that Senki is going to, and then she's going to bring those goggles there. If you have an interest, then you can wear them and look at some of these scenes that we're showing here for that we use for this study. Then the other way that the participant looked at it is simply in a web browser. You pull up a web browser and look at exactly the same scene you see through goggles, except that it's not immersive, it's on a flat screen. And we did this in a 2-phase. First, we conducted the VR, and then 6 days later, we conducted the 360 survey. So here's a quick video that shows what the participants were seeing in those scenes. Let's see. Maybe I should just click somewhere. There you go. You could practice as much as you want. So the scene on the left is the urban center. The one on the right is general urban. They are from the sort of similar points of view. And we have 5 different points of view that the user can change to be able to explore the space. So this there were 2 from the sidewalk, 1 from vehicle lane, 1 from the bike lane, and 1 at the intersections. So you can see down there the pointer, that's in VR, where you change, as you all know, change the scene and explore it interactively. Whereas when you do it on the screen, you can, if you have a touch screen, you can simply click or continue to do that with the mouse. So once the surveys were completed, we paired the VR and 360 scores from each participant and conducted a statistical analysis, testing those scores. That analysis also include looking at association of participants' background with their score to see if there was an effect from those. So ready? Drum roll. Here's the findings. People scored more or less the same for these scenarios, whether they're using VR or 360. So we didn't see any statistical significant with the score of those variables, except for realism. So the other 5 were about the design, right? About their perception of what they're seeing, whereas realism is about their visualization. VR realism was significantly higher than 360. So this is, so good news for us with like VR, right? So it's still good, right? Don't discourage. Realism especially scored higher for general urban. So we have 2, right? The urban center, that's more like denser city, and then general urban, more or less a little bit more like a suburban kind of zone. Then in terms of participant background, we found that people with prior VR and or video game experience gave higher scores when using the headset. I guess that tells you that they're probably influenced based on their experience. And another interesting finding is that when we asked about the density, people that used to live in dense and used to urban areas thought that the density we're presenting here was not big enough, large enough, right? So they provided lower score to density. In terms of preferences, participant with prior VR or video game or design background would strongly prefer headset, and then younger participant would strongly prefer headset as well. Not everybody, but the younger portion. So in conclusion, I wanted to point out a few takeaways. So if you're assessing a street space in a vibrant urban center kind of environment, right? Then the visualization method, regardless which you pick, the visualization method is unlikely to affect design assessment, despite the preference for the VR immersion, right? So they do have that preference, but which means that, you know, if you're around a bunch of people and ask them, and basically ask them for their input on that design, you could use either the methodology, you'd get the same result. That's the point. Which then the takeaway is when we do these studies, you know, we have the overhead of VR, right? It's cool and everything, but with 360, you basically would pretty much get the same result from the audience. So you might want to think about the trade-off and the practical implications, especially in public meetings. So do I have to have the pressure to absolutely have VR? Again, it depends on what they're looking at and when you're studying. Headset, the immersive VR provides higher realism compared to 360 overall, but especially in streets with fewer features and lower density. This is kind of interesting, right? So when you think about it this way, when you ask them, let's put it this way, if the design is good, which we saw in urban center, that has a vibrant city and there's lots of street furniture and good enclosure and so on, they weren't influenced by the visualization mode, right? But when it comes to suburban kind of where you have fewer features on the street, a little boring, you know, lower density, they thought that VR, they would give higher score when they were looking at it through the goggles versus when they were looking at it on the flat screen. So in a sense, VR helped generate better scores. So we need to be careful about this because, in a sense, you know, you could say, well, let's just do some cool visualization and we're going to be able to sell an idea that's probably not the best, but because it looks great, right? So that's a bit delicate kind of finding. So, but everything that I said in terms of findings should be taken with a grain of salt, right? We know that. So as in all research, we have various limitations. For example, we used limited design scenarios. We built two and we went with those. We did create more variation because it makes these studies a little more complicated. Our survey sample is what they call convenience sample, right? So we basically use people that we could find, and it's definitely skewed to college age participants. Other design variables should be tested. We picked those 5 because they are sort of try to be comprehensive, but there could be more that can be tested in more detail. The other concerns that we have is the order of testing, right? So the way we decided to do it is VR first, 6 days later, 360. We didn't test the other way around. And does that make a difference? That's why we always have future research, right? There could also be some memory residue from first survey. Like we've been looking at, you know, the psychology and how people remember stuff, and we found that after 6 days should be safe. But, you know, I'm not sure, right? I don't know how much that really affects the score when they looked at the 360 after they've seen about the same thing, but in goggles. And then the visualization part is limited to the realism aspect. So we didn't ask them how easy it is to use or how interaction with the model is addressed. And, you know, if you just look at visualization per se, you can certainly ask more questions. And I believe that is my last comment. So we can thank you, and we can open for questions and comments. Thank you. That we didn't test. The current testing is interactive. So if we wear the goggles, you can do a couple of things. You can move your head around so you can see around. You wouldn't walk, but you have those little, there's some little markers on the screen where with the controller, then you can jump. So in a sense, there is some interactivity there where you jump to predefined points that we've defined. And likewise, it's the same in the VR. It's the same. So this is, for example, and I have a flat screen, so I could just do this with my finger. So for example, this is one of the VR scenes. See those dots here at the bottom? Those 5 in there? So this is where you would jump to these predefined points of view. If this was in goggles, then you would see those and you would click on those on the screen. Now that we don't have goggles, you can just click on these and you can jump onto these different areas. So you can zoom in and out and you move around, but not like more naturally walk. So that's a limitation, and that probably is going to require a little more work. It wasn't directly out of the box to do, whereas what was here, we just simply converted from City Engine. We export these scenes as VR, and then it loads in a server, and then you can just, we can share the links with the presentation, then you can go there and just look at them on the screen. And if you have goggles, then you'll be able to look at them in goggles. Yes.
Thank you for the presentation. I had a question about how you built your model. Could you go back to that slide if you don't mind?
Absolutely.
Thank you.
We kept this to a minimum.
Okay. Is there any particular order that you follow when you're building the landscape, the model?
There is definitely a very, very good question. So there is a general procedure you would follow, right? So what we typically do and recommend is that you start with GIS data, right, for the broader area. So bring those in. And then if you already have building footprints or existing, especially if it's an existing environment, existing conditions, then import those into this city engine from other sources. And this is georeferenced. So if those objects are georeferenced, so they will come and show up in place. City Engine also has a foundation for like the base map, right? So you could choose the base map, the aerial photography, and then all those will create like an initial view or initial model. And then you can go run these rules and create streets and buildings and blocks and by using this rule-based engine. Once you've subdivided and creating the sort of the foundation of the layout of the block structure, then you could go on the street and start creating various street scenarios. So one scenario, as I show, is this urban center where we have a median, we have bike lane. In some cases, we can have like a dedicated transit and so on. Or you could create another scenario with a regular, 2-lane on each side, sidewalk, or just, a separate minor division, and then you can have parking lots and other things like that. So it handles well the entire cross-section of the street. And it does it by these rules where you don't have to write from scratch, you just change them interactively.
Awesome. Thank you.
Yeah, you should take our course. Talk to Senki.
I have a question about the device, because we are comparing the VR and the 360. So I know you mentioned about the VR headset during the presentation. Do you think that the different type of VR, because they have different resolution, will that have an impact on your result? And also, the 360, are you using a screen? What's the size of screen? What's the difference if you would just like watch using a tablet and you just use a projector?
Excellent questions, right? So those basically variables that need to be measured. So the 360 VR, it was Oculus Quest 2, right? Anyway, we don't have to go there. The resolution of that is what it is, right? So all participants just use the same device. However, we didn't test what impact that does if they were to try different devices. Some that are, super high resolution, and some there are less. So that's something that we haven't tested, but at least we stayed consistent using the same across the participant. The second one was about the flat screen, the size of the screen. This one, we don't have an answer neither. It basically, we gave them the link where the models are loaded and they can pull it up, and they did this on their own without supervision. The Oculus, there was basically in my office, and Senki conducted the, administered that, but they did on their laptop. So some people have a small screen, some people have a bigger screen. I think when we saw these results, remember like 10 years ago on the TV market, all the rage was about the 3D, with glasses, and so I bought one of those TVs, never saw anything on it. Nowadays, if you go shop for the TV, there is no mentioning of that. Instead, it's pushing all toward the resolution, right? The 4K, now 8K, because I guess the resolution is very important. And I think, in a way, this points to that, because the quality, all the participants indicated that they like the realism of VR versus the flat screen. And it's the same resolution, obviously translated in VR, it can come across differently in your brain. But what we're guessing is the immersion. The immersion, because it's a whole different thing, obviously, for all of you that tried it. When you get in there versus the flat, which is your distance from it. But if the design is really good and they you know, apparently the visualization mode doesn't really affect that as much. So there's some of these that are still unanswered, and we would like to look at them further. Good question. I've got 1 minute and 30 seconds. Any other question or comment? Yes?
Any other plans to try and study any the less convenient participants, like maybe an older age group or anything? You know, people are may less have that experience in video games and the other things that you said led them to that.
That's a very good point. And again, I have to accept that it was convenience sample, and we got these guys, and mostly, you know, college age, some a little older, but so we've been talking about plans to reach out to the city and then try to do this more realistically with, you know, citizens and so on, and to see what happens. There's practical challenges with that, with the VR, and then getting people to, because the 360 they could do at home, right? For people that have a computer, all they need is a browser, pull it up and look at it, right? But for the VR, then you gotta have to organize it somehow, because we can't expect for them to have an Oculus Quest 2 or, you know, dare to buy the new one, $1,500. Did you hear that? They're putting a new version, $1,500, and my brain went, what? I thought the price should go the other way around. But yeah, so that would be interesting. We have talked about trying to follow up with that, and we'd like to hit DOT for some money to do another grant to do this. Well, thank you. So my time's up. If you have more questions or comments, then we can chat afterwards. So we need to jump to the next presentation. So I will close ours here. Glasses. There you go. And then, before you start, I'll give you a quick introduction. Oh no, let me stay here because otherwise people won't see. So our second presenter, Andrew Poszich. He is a PE and has been with RNS&H since 2014 and currently serves as the Design Integration Lead for Infrastructure Strategy after spending many years in the Highway Design Group. Andrew brings an in-depth understanding of transportation design and overall three-dimensional workflow as it relates to core engineering principles and interdisciplinary collaboration.
Thank you, Lear. All right, folks, so this actually kind of coattails pretty well after the last presentation. Specifically, what I'm sharing with you today is kind of went through and trove our archives of some use cases of 360 media. The discussion with VR and 360, I think as we evolve over time, will adapt and change as the technology continues to improve. But what I want to share with you guys today is how approachable 360 is, not just in the traditional sense, but some other use cases that are found throughout industry. So there's some foundation this is all built on. As kind of earlier mentioned, I am from a roadway design background. I do a lot of work with 3D modeling and a lot of that CAD data that we already have. So there's a lot of ways to get 360 information, but to me, it just all starts in the model. So if I have a 3D CAD model already created, I can easily kind of roll that into a visual product. OpenRose Designer is my bread and butter. LumenRT is a nice package deal that kind of goes with that. But that's one of the foundations upon which a lot of the content will show. Next up is the idea of engineering visualization. To me, this idea represents a changed policy where visualization doesn't always have to be a high budget production. It can be as simple as just taking a model, exporting it, into an environment where you can better understand. So having that sense of utility is sometimes more important than aesthetics in certain use cases. A lot of this is driven around public engagement. I think that's where a lot of this gets started, a way for the non-professionals out there in the world to understand what we're doing. For me, coming into industry out of college, I expect the world to already be in 3D. But what I found back 8 years ago was you have plan, you have profile, you have cross-section views, and you're assembling those in your head to understand what this design is. The public can't always do that, so being able to bring these design to life, whether it's a 360 image in this case, photo sims, 360 imagery is just a big part of a larger story to tell. Which all brings me to kind of the idea of interactive media. How can we drive some of these 360 photos to be more than just a viewing experience and actually provide some meaningful interactivity with the designs out there? So just a brief mention of starting off, 360 images do a great job of simplifying a 3D model. I started off back in using LumenRT. We have since moved to Unreal and some other products. We have a dedicated VIZ team. That is not me. So you start asking me about those questions, I will direct you some of other more intelligent folks in that regard. But it's become more accessible to use 3D model. However, that integration into the 3D design isn't always accessible for the average viewer. Oftentimes, it takes someone who can skillfully navigate the scene. LumenRT specifically has some base interactions, and as was kind of mentioned in the previous study, if you have a gaming background, this comes second nature. But if you bring this to a public meeting, there's a significant time of upstart to navigate. I am hopefully navigating here somewhat smoothly, but as you can see to onlookers, maybe it's disorienting. It's not always easy to follow. However, there is a lot of benefits that come with that. You have that free flow navigation. So we are kind of taking sacrifices, but I do just want to show out. And here you can kind of see I just tried to simulate falling into a hole. The average person might struggle to navigate throughout the model, may get turned around and a little disoriented in how things work. To me, that's where 360 images come in. We're able to create these 360 project tours that are very easy, very forthright. People can click around at their own discretion and explore the project at their own pace. The simple interface, oftentimes mobile compatible. So what I love about these tours is I can pull up my cell phone, I can kind of look around, get that simulated experience without any special hardware. So the portability is nice. Usually no cost at all, if not for your average consumer who has a cell phone or a personal computer. If you're engaging with the public at a public meeting, having a station set up available is also easy to do, or even a tablet. And as you can see, we have a slightly different model here, but a kind of easy experience. Again, this is all CAD data. That's a lot of my focus is going to be. It's not done in the highest quality render engine. However, it's accessible, it's approachable, it's not going to break a project's budget, which to me is always important at the end of the day, is how much is this going to cost our clients out there? How much is this going to cost to develop? And what it does is it gives meaning to just that static render that you might create. You can check out different perspectives. You can understand different points of view as you navigate the project and use it as a discussion point. Someone can ask a question as you go along. Maybe you're over someone's shoulder. Working through a lot of these areas in traditional means can be kind of complicated. But using the 360 media does provide you the additional sense of realism. And in this case, we're using built in the LumenRT has a, it's called like LumenRT 360 Project Tours. It's included in that software. But there's other software out there that does the exact same thing, as you saw earlier with the City Engine as a great example. Unity does it as well. So that was talking through a project, public meeting. However, you have a lot of times folks out there that want to understand their physical location a little bit better. So maybe what we want to do is recreate something similar to a drive-through experience without the kind of what can be considered a nauseating feeling for some folks. So what I'm imagining here is to be able to bring that content to property owners to understand what actually looks, what this proposed design would look like outside their property. And it allows them to explore it at their own pace in a very similar experience to what you might see in Google Earth Street View. So you can almost see someone taking an exit, understanding what that approach might look like as if they're sitting on top of a Google Earth streetcar. To me, that's a very relatable tool. A lot of us in the industry use that tool almost every day when you're working on existing conditions. Not everyone sees that as a easy and clearly defined methodology, a way to navigate. However, I think it's something that once you simulate it and someone dives in for the first time, it's a very quick thing to pick up. And it's not something you have to spend time training someone over the shoulder. Simple click, drag, rotate. And here we have a few different points of views. But again, I'm not worrying about the background contextual data. This is someone who cares about what's happening outside their property. and it's the 3D CAD model that we're bringing forward with that. So not a lot of extra work, just some simple materials applied, and we're giving them an understanding of what that complex set of plans might look like. Flip side, similar area, you can actually take those 360 content and bring it into a 360, or in most cases, a 180 drive-through. And you're able to take that information and give that driver's perspective, give them the option to look around. You can always render that out as a standard image. Arguably, sometimes that's the easier thing to do. But this allows people to understand what they'll be experiencing on the road, analyze some sight distance, identify different obstructions, and be able to assist with the kind of aesthetics of the corridor. What we like here is the video, lets you play it. Windows Media Player is kind of default. If you have this set up at a public meeting, you can have them kind of look around. Again, I'm sharing a very low quality example, but again, just underline the fact that this is from CAD and it's an easy product to generate. If you have project or budget for it, we have some more polished versions that we do for those large, kind of large, high profile, like high contention projects that you can do. But in this case, we had a simple stakeholder that was interested if you could see basically in their backyard. And through this quick one-day turnaround, we were able to showcase that, hey, your backyard is fine. It's 100 feet in the air. If you're doing anything up there, people can maybe pry. A few other use cases. Showcasing a slightly different tool used by our visualization team. These renders are a few years old now, but this was early stages. So even if you don't have a full design, you can start benefiting from some of the 3D models and the 360 images. To view those concepts at your own pace, especially when you're pairing it with other public engagement strategies. In this case, also coming from the state of Florida, just a unique design was proposed. We wanted to give associates and users and stakeholders and everyone involved just a better understanding of that design. So with a simple context navigation map, you're able to take that idea that you might have been presented on at the public meeting and go back home with it and understand, hey, do I have any follow-up questions? Is there a way to engage with this content beyond what I was told and standing in front of a person? You can also maybe solicit feedback through 360 medias, which I'm going to showcase a little bit later, and able to understand how things like streetscape and landscaping and everything can kind of play in together, as well as a little bit more about the surrounding areas. This benefits over static images, just the ability to be able to truly navigate the scene and understand different points of view as they relate to each other a little easier than if you were, say, looking at a roll plot, which is a lot of the challenge trying to translate that imagery. And PowerPoint is crashing on me. Sorry guys, small technical difficulty. Yeah.
No, nothing. Can you close it and, oh. It's on the desk.
Yeah, we're gonna jump back in here real quick, guys.
They're knocking around leaves.
All right, we're going to jump back in here. Hopefully didn't eat up too much time. Oh, not from the beginning. I want to do from current slide. All right, so continuing on about 3D concepts, another thing you can do is use them for concept comparison. So as you're viewing different concepts, yes, you can do those in side-by-side renders, but this gives you a greater kind of understanding of how those concepts can apply through a slightly different interface. So being able to switch kind of back and forth in real time. Unfortunately, 360 photos are a little finicky. We've come to find getting your orientation correct when you swap them. Probably different programs out there might have a better chance of it. This is from a few years ago. But what we were able to do is take that same roll plot image that you might be used to seeing in a public meeting and use that as the foundation. So we can go back, and if you had a question in a certain area of the roll plot, you're able to jump around that roll plot to see where the area is. In this case, you're actually going to someone's balcony. This was a very high profile project, introducing a whole new corridor, introducing noise wall. So to be able to say to all the stakeholders in the room, yes, we are confident your view sheds will be unimpaired. You can still see across the corridor. We're just helping to alleviate some of your traffic congestion issues in the process. And you can see you can intermix other media as well. There's some 2D renders in here mixed in with the 3D, kind of differentiating the two. So just because you're having 360 image base doesn't mean you're limiting yourself to that 360 experience. And being able to actually go in and apply it to other aspects of the corridor. And as you notice throughout this presentation, I am using different 360 tools too. So that's something to keep in mind. If you've identified a tool that works for your group, doesn't mean it's the only tool out there, and there's definitely other tools that you can bring into your workshop depending on what your needs are. One of my favorite is just sending a drone up in the air and taking some panoramics. Being able to use that to help understand the context of your area can be used not only for public engagement purposes, but can also be used by the project team to get maybe more up-to-date information. That street view image might be a year or two old. However, if you can send a drone out or capture your own 360 images on site, you're able to get something that is like Google Earth, but much more relevant and up-to-date. Here's just a quick example we threw together of using a panorama, not even a 360 camera at this point, just a drone that has the capability of rotating around. And we're able to kind of walk the project, or in this case, fly the project, to understand how the different intersections work. Unfortunately, this wasn't at UF, but this was at close by at FSU. In this case, we were doing an intersection study. Very high level. We were out there capturing imageries. This ultimately went into some photo simulations that our team put together, but we were also able, while we're out there with the drone, to capture some additional information that we actually use during conversations and meetings to help better showcase the project. Kind of taking a 180, where you're using 360 imagery content, but now we saw kind of an example of a pre-project, and now let's talk about post-project. We actually partnered with FDOT here about a year and a half ago to showcase some of their projects. There's a pretty cool website out there. I don't know why I didn't make it a slideshow, but it's FL Complete Streets. If you Google it, we did some cool things with 360 images on that site, and we were able to take that together and put it into a website that hopefully helps educate the public on why we're spending all of this money to enhance the safety of certain areas. So what we used, we're actually switching now for the third or fourth times to a product called Kula, where we're able to kind of create this interactive experience and link it to other media sources. You're starting off looking at a map of Florida with some tour instructions, and you're able to kind of jump in and move around. So now I'm enhancing my 360 imagery by giving it a little bit more sense of context, more sense of scope. I'm using it to almost tell a story versus a traditional story that maybe would be in a slideshow or in a different medium, where I'm giving the one experiencing the story the flexibility to kind of go at their own pace. So they're able to jump in, see the project, learn about it, experience some of the qualities of the project, the benefits of, in this case, a complete streets overhaul, but also have access to that back-end data. We can link them to other content that exists outside the 360 tour, and to really dive in to some of the more informational or educational aspects of the process. And what's cool about these kind of products, there's Cool is one of many, there's a few others out there that you can actually really are just limited by your own creativity. If you have certain needs of a project that need to come into play, you're able to identify and adapt. You can insert media, static images, video, what have you, in order to make that happen. In this case, kind of learning more about drainage infrastructure that might have been installed, or some other media entirely. Let's see if to try to catch back up on time here, if I skip ahead, if it doesn't crash it. There we go. Taking the same idea, same FL Complete Streets project, we wanted to focus on public involvement in the idea of complete streets. So now we're using 360 imagery to help showcase why, not just why we're doing this on actual projects, but the idea behind the project itself. In this case, varying on different context classifications in order to educate those outside of industry and to help leverage some of those tools to provide guidance to those in industry as well. So we're trying to target two different markets, but what we felt was a creative use of 360 images. And in this case, we actually embedded them within a story map, which is an Esri product. Great tool if you haven't used it. If you guys are using Esri license, you probably have access to it. You're able to use these same models that we are using to generate the 360 images and also use them to help educate and inform as you go through. And then once you get through here, we're going to skip ahead a little bit just to make up for the crash. And of course, it's not like in this either. I'll try this one more time, and then if not, I am going to keep going. But we're using the same image you see on screen, and you're able to jump around in 360 tours and to kind of look around within that image, using the same tools that you just saw, clicking on information, learning about it, referencing standards, whatever the situation might call for. This one, I'm just going to jump right into it, is the idea of using 360 images on what I consider unpolished geometry. So here we actually use this in conjunction with story maps as part of a constructability review for a project. So being able to jump in, use those 360 images to not only kind of put together a talking point list, and as you kind of scroll through, you see the benefits of the render. Again, very high quality. We had discussion points about, is a wall constructible? But you're actually able to jump in and use that 360 tour as well. So before your meeting, people are actually able to walk the site, understand the project, and have a better purpose behind their questions as they go into that meeting. You can jump in, zoom to different locations. I can jump around different spots, walk the project, kind of bounce around and see what I'm looking at. And we use this during the meeting. So if you imagine going into a field review, you're out in the field, you're kind of walking, talking about what things are going to look like. This gives you a great sense and purpose of what you're going to be discussing before you actually get out there. So we started off with a pre-meeting, discussing it off the model, jumping around, and then we went back into the field to actually discuss those points that we already previously laid out. This actually goes into the discussion points of being able to use 360 videos, which we'll get here into a second. I've learned to give PowerPoint its patience on this one. Apparently not enough, but to try to make up on some time, we also had a 360 animation fly through, so you can fly through the corridor, pause as you go through in order to see what the end results would be. And then just kind of to finish it all out, all this can be brought together through a virtual public meeting. That's another great use of 360 images. Unfortunately, throughout COVID, there's a lot of negatives that came with it. One of the positives that actually came was the accelerated use of technology. And there's some trends in industry projection out there that said we had about a 3 to 5 year leap in technology adoption rates. One of those was for public meetings. So being able to use and to kind of recreate that experience for people in a 360 environment was a great use. So we start off with our video, introducing people to the space, welcoming them to the environment, and then letting them explore the room, talk to people. So now we're really leveraging 360 environment to give people a sense of presence in that area, to understand what they're doing, and to increase engagement and interactivity. Of course, you can have videos, you can have whatever kind of content you desire, but you can also leverage that to gain some additional information, or maybe you're using it in this case to solicit some feedback. So what we're doing after the public engagement meeting is we're sending out a survey to ask them the questions, but we're also giving them a sense and experiencing the same thing they've experienced in the physical meeting. So this case is more of a hybrid approach where you have the physical meeting and then you're able to show a kind of walkthrough afterwards in a virtual space to understand and kind of collect thoughts and ideas around with that information. And with that, I will close out with a quick reminder. The reason we use interactive media is to drive engagement. To me, being able to participate in something is way better than just sitting back watching. We found that a lot with the respondents of some of these public meetings and other interactions. It gives people more time to digest the content at their own pace rather than just following along with the video. It allows you to be specific in different regards. You can do a broader approach where you can focus on education, and whatever you do, it needs to be accessible. That's more or less it. If you follow the PowerPoint, I have some links to some of these, but I think I have like 1 or 2 minutes for questions. Yes.
which looked really nice, but seeing the picture,
Yeah.
I was like, well, that would be really loud with the cars driving overhead or like from the noise walls that
Yep.
you're adding.
Of course. Basically, the question was, we have a audio component to all of this as well. And for about half of what you've seen on screen, we also had a VR version of it. So specifically the ones around the public hearing, we have a VR headset that can be ran and compatible with it. And then for those experiences, we do like to add the audio. One of the biggest questions we get from our clients is, hey, how about emergency response vehicles? Or like, how does this sound impact? So in that sound study, for instance, you can add different audible levels to see how that noise level would impact. Of course, there's some level of discretion about how much sound's actually blocked, but it gives people that sense. So we do add audio if it's more interactive. Of course, for the 360 images, we're kind of just looking at a picture. All right, any other?
I have one question.
Yeah.
I just want to ask about the project itself. So, are you, the project is that digital project delivery or still like a paper-based? Because I saw that one maybe help the persuade like a DOT or to accept the digital project delivery.
Yeah, so unfortunately or fortunately, the clients are all at different stages, right? So if you're in industry, certain states are ahead of other states. Unfortunately, got my start in Florida, so Florida's kind of pushing ahead with digital delivery. I think starting this November, actually a few days ago, they released the mandate on their new standards of forcing our hand on digital delivery with 3D model-centric design. So it does play effect, especially from a marketing's perspective. You can say, hey, we already have the 3D model. We can give you the visualizations for just a little extra effort. But it varies based on client. And we will try to market this, of course, as with most private consultants. It's kind of a double-edged sword where we're excited about the technology, but it also kind of gives you additional value. But we're here to share it, so we're excited for everyone to kind of push together forward on this front. I think we had one more hand up, and then
Real quick, I think hopefully, is there a way yet to get user notes or comments directly in this tool, or do you foresee a way for that to happen to kind of eliminate that gap between providing the feedback after saying like, oh, look at this specific feature or something like that?
yeah, so there's two different things that we are currently doing, and then there's a third that we're actually researching and investigating now. The last one you kind of saw on screen is there was a survey, so you have them go through the experience, and then immediately following that experience, you survey them on the results. It's probably the easiest. There are products out there now that are starting to come to market where they are design model-based solutions, and then you can actually ping a location and comment. We've developed that ourselves, but we're at the point now where we're looking for third-party solutions just because they have a full software team dedicated to making that experience as smooth as possible. I'm trying to think of some offhand, but I actually have an email next week that I need to get back to you for that. So if you want to talk afterwards, I can probably find you names for some solutions. With that, thank you. Try and make up some time. Oh, 3 more minutes? Oh, okay. I didn't realize. I thought I was rushing to make up some time. I'm looking at that clock back there.
So I have a quick question.
Yeah.
First of all, a comment. I think you made a really good case for the 360 with the application that you showed and all the benefits. And the quality, the high resolution, I think it's something that we also find that people appreciate. Just a quick technical question. The ones that you showed, that you use Lumion RT?
Yeah.
Are those pre-rendered or are those real-time, just like a game engine would produce content, and then you interactively work with it? Like these?
Yeah, so specifically back here, this is the Lumen RT, for those of you who aren't exposed to it, is a Bentley acquisition from a couple years back. Now a Bentley product included in the Open Roads Designer Suite. It is a real-time render engine. However, if you remember that very first example I showed, it doesn't always have the best value to bring to the table. So what we'll often do, if we're not in maybe a local kind of working meeting where we may jump into the Lumen RT model, if we're going to the public, we usually go ahead and render something out statically. So this is a static render based off that real-time scene though. So if you so wish, traffic can be moving, trees, you can add your audio sources for sound, and give people that experience. And what we like about this is, since it's coming from the model, it's relatively easy for us to generate. I mean, we're sacrificing some peripheral information, of course, from like a aesthetic standpoint. But I think this scene took us maybe 2 days to throw together from the 3D terrain. So that's terrain data that we're designing off of. We're draping over some shapes. We're using OpenBridge for some actual bridge data. We're using the actual pavement design just to drape this draping on top. So it's all real data. And you have the ability now to access that from 360 media real time, or even virtual reality if you just plug in your headset to LumenRT, it starts up in your headset, and you're good to go. So you kind of have some flexibility there. But yeah, static is usually our preferred route.
That's a good nuance as an option.
Yeah. Yes.
The one you had with the plot and then the points, different points you can go to, how was that generated?
This was done using a software from our VIZ team. And let me jump to let me jump. Yeah, if you guys download this online, I included the links that I'm able to share with you here. I'm going to trust this source, hopefully. No promise, no viruses. It was Collateral was the website that we used for this one. I don't have as direct experience. I am from the design side, so my bread and butter is LumenRT and Kula. But we were considering switching over, and I think we just took another perspective here as well from a different application. So there's plenty of offerings out there. Look around, shop around. I think we're seeing a pretty heat up of the market.
You'll be around in this conference.
Yeah, I'm here today and tomorrow. So if you have any follow-up questions, I can leave some business cards here too. I'm happy to reach out. I'm excited and passionate about it. So let's talk.
I'll be around this conference. Okay, so, sorry, I need to be here. Our third presenter is Dr. Haowen Su. He's a research scientist in the Computational Sciences and Engineering Division at Oak Ridge National Laboratory. His research interests preliminary include developing digital twins, visual analytics, cyber physical systems, cyber infrastructure, 3D smart cities to support urban research and management from a holistic aspect.
So good morning, everyone. My name is Haowen Su. As like previously introduced, I'm a research scientist. Today my topic is basically using photorealistic immersive virtual reality digital twin and visualizations to support driver's training. And one of the co-authors, a major contributor of this project, Dr. Andy Barris, is actually one of the audience here. So in this presentation, primarily, actually, it will synchronize with the previous two presentations too. And here I'm going to approach the generation of the digital twins and the 3D city environments from the GIS and from the scientific gamification aspect. So I'll start with our motivation. What do we want to do? We want to generate a 3D realistic, photorealistic environments to help our transportation researchers emulate real-world driving experiences. What I mean is everything should be replicate the physical world, like trees, buildings, and everything should be geo-referenced and can be put into a game engine or a professional traffic simulation software and a simulator to support both simulation and co-simulation. So here are some of the use case we have. We can do training, we can do virtual tour, and the serious gaming is derived from the scientific gamification aspect. Basically, it's not just a 3D visualization, it's actually connected with the actual scientific simulation softwares like a VIZim or Sumo software. If you are like, there are any like simulation experts here, then basically reflects the scientific modeling results in real time to the 3D environments so that the users can interact with it, and they can also get additional insights from the model-driven approach. And then we have another aspect that would be the training of the machine learnings and AIs. So we can use the computer-generated graphics to train the to train the algorithms for vehicle detection, for pedestrian detections. So here's our research need at the Oak Ridge National Lab. We have a driving simulator. It's called a Connected and Autonomous Vehicle Environments. It's abbreviated for CAV. So what it does is it's mount a real vehicle. It can be an autonomous vehicle. It can be a traditional vehicle on the dynamometers, and then connect the dynamometers to a high-performance computing device that loaded with different traffic simulators. And then in that setup, we could, test the following like research needs. Basically, we can conduct autonomous vehicle driving test, the detection capability of the vehicle through the computer-generated things, and then we can also do a traffic co-simulation. The user can just act like a real drivers and control the vehicles through the dashboard, through the steering wheels, and that will reflect in the simulation. And then we have a driver's training. Basically, that's connected with the scenario generation task. Generate different weather condition, lighting conditions, like a pedestrian or traffic safety conditions to help the drivers get familiar with different policy, traffic rules, and also to improve the driver's situational awareness capability. So here's our study area. We use our Oak Ridge National Lab main campus as a study area. Many regions where many road sections in the campus are IoT connected, basically mounted with Internet of Things sensors, like for traffic cameras, for the RDS, the radar detection sensors. So we also develop another digital twins to aggregate all those information. So through one portal, you could access all the traffic information, conditions, availabilities of EV charging station and parking spots. Here are some of the previous work conducted as a lab. So we mounted, my apologies. So we mounted like a LiDAR system on autonomous vehicles and drive around the lab, and then basically sense the 3D data point clouds in the vicinity of the road. Then we pull that into driving simulators, actually two driving simulators. One is an IPG car maker, one is a VTD, and then we could simulate different driving scenarios. But the limitation here is it doesn't have the surrounding environments, doesn't have a building infrastructure or other dynamic properties or entities. So what we're trying to do is we want to create a photorealistic gaming environments to conduct scientific gamifications. So our approach is basically a metaverse city approach. So that's a very hot topic, attracting a lot of investments and imagination from industry and also public service agencies. So what we do is it's actually the metaverse concept itself is built on top of the digital twin and the cyber-physical system. So we have a digital environments that 100% replicates realities, not only the physical presence, but also the dynamics through the sensors and also through the real-time simulation and predictive modeling approach. Then we mount all those, we deploy all those on the cyber infrastructure, so we can create a gaming environment that actually the user can interact with the environment and also interact with each others, as well as the scientific simulation behind it. So here's our previous work. First I'll approach from the traffic simulation side. So there are two tabs here. The first one is basically in the traffic simulation domain, there are very mature pipelines that can generate 3D road networks with like a synchronized connection with the actual traffic simulation models. They can just take OpenStreetMap networks and import it into Carla and generate the very famous OpenDrive format. Basically has a lane information, lane specification, and also markings. With a different selections of tools, you can actually get the very realistic road surfaces with the real markings and the traffic rules attached to it. And then you could import both the OpenDrive file and the 3D network generated from the Poszich into different simulation software like Sumo and VIZ22. And then after generating the simulation scenario, you can import the entire thing into the driving simulator enabled through IPG, Carla, or Unity. So what's missing is how do we generate the surrounding environments using a very low-cost, adaptive, and scalable approach. So if we hire a team of 3D modelers, and that would be time-consuming, and that will also be labor-intensive as well. So we want to propose an approach that using the open geospatial data to generate all those 3D environments, the quality might not be as good as the like the modeling approach, like used in the movie making or making industry. But in this approach, we can extend our digital twins to a larger spatial scales in a semi-automated or automated workflow. So here's an example. That's one of our projects initiated from the Sustainable ORNL Campus projects. And then it's keep building, and now it's evolving into another project called RealSim, sponsored by the DOE. So that's one of the entrance gate at the Oak Ridge National Lab. You have on the left side, you have a Google Earth environment, and on the right side is the our like photorealistic 3D environments we generated using a GIS workflow. So to generate these environments, we have to classify different scene objects. Like normally in the digital twin city, you would have buildings, that's the actual checkpoints, and then you have a traffic infrastructure, other energy infrastructure, the road infrastructure, and you also have a miscellaneous objects like other cars, like a deer crossing the road. And in our environments, everything is animated, so it's not just a visualization, it's more like a scientific-based Grand Theft Auto game, and everything has a property, has animation, and also has its behavior scripting. So here's the GIS pipelines, and individual types of entities are corresponding to different data sources. There are static entities that's basically acquired from GIS data, from remote sensing, from photogrammetry. There are also computer-generated entities like other moving car, pedestrians, and such. So then we import all the gathered information into modeling environments. In this case, we use Blender GIS to integrate all the models together and then import it into the Unity. And then we could create a gaming experience. And the other traffic simulator that has been popular in the traffic simulation domains like Carla, IPG, they are derived from the Unreal Engine and other major game engines. So they do support our exported formats because we use common 3D modeling formats here. Here we jump to the data source. So as I introduced the pipeline and how do we get the data, so here are some data sources we experimented that generates the terrain. So we have USGS 1 meter LiDAR that has national coverage. The NED data from USGS, that's 10 meter coverage nationally for most of the region, I would say. And then the NOVA provide a very good platforms you can download LiDAR data along the coast. Then we have the global coverage NASA space shuttle programs, but the resolutions are not as good as the previous two. Then we can apply the Google base map or from the Google Earth to apply the base map, the coloring to the point cloud so we can generate the actual 3D meshes. So for the buildings, we use also a city engine to export some of the buildings, and some other buildings are extracted from the 3D CityDB and also from the Cesium 3D tiles. The Cesium is mostly the 3D point clouds. And then here's simple pipelines. How do we convert LiDAR data and DEM raster data into the 3D common formats? And then we can integrate with other 3D property and assets into the virtual environment. So here are some other aspects. How do we generate the environmental variables here? For some of the infrastructure, we can fly a UAV and we conduct aerial or close-range photogrammetry, basically taking pictures and using softwares like ERDAS imaging and Agisoft to generate the 3D meshes so we can separate the actual infrastructure from the terrain and assign it property for gaming applications. And then all the environmental scenarios are generated with particle effects. So you can create them, you can also purchase them from TurboSquid and Unity Asset Store. So here's a glimpse of our 3D environments. As you can see, it kind of replicates the actual campus, and then you can apply different skybox, different environmental variables, and then we import it into a driving simulator. And users can just control the little vehicle as an avatar and to explore around. So here are some use case demonstrations. So that's one of the case for traffic safety trainings, simulating the scenarios when the driver is driving down our Besser Valley Road in Oak Ridge, and in a foggy day, while there's a deer crossing, and basically it's a deer showing up the headlight scenario. Another use case is we generate a computer generated graphics to train our machine learning, our computer vision model for vehicle detection as a parking lot. So through the 3D things, we can, through the 3D environments, we can generate different weathers and the lighting conditions, and the computer generate graphics automatically carries labels. So you don't need to hire somebody to label the vehicles or trace the outlines. So everything is more like an automated workflow. And then here's another application on the scientific gamification. It's digital twins that informs the lab or campus managers on the operating status of their off-road vehicles, construction vehicles. Every vehicles are internet connected, so that when they move, when they do different actions, it will trigger different animations, so that the lab directors or the managers would know what they are doing, where they are, how they interact with the environments. Then here's one of our demonstration. It's not the best rendering. It's basically using a Unity deploy as a web application, and people can access it with a VPN and URL. And that's basically a night driving experiment. We have a little car. That's our quad area. Then we have a visitor center here. Our supercomputer is in the buildings behind. You can, actually it's pretty remote. So everything is generated with the GIS data, so that make it more scalable and adaptive, and you can easily apply them at a larger spatial scales. Then we have another showcase. It's not traffic related, but it's basically rendered through the same pipeline we developed. It's more like a building energy modeling visualization. You can basically integrate your floor plans together with a RC building temperature model, okay, and then visualize in real time in a 3D environment. And since we generate the digital environment, that can be used in different platforms. It can be visualized in Unity, can be visualized in a driving simulator like a Carla, and also 3GS. And with the 3GS, you have the flexibility to visualize this through the browser or through Oculus. As you can see, there's VR buttons down there. So it's more a cross-platform approach. So here's our discussion and future visions. So in future, we do consider connecting our 3D pipelines with more scientific models to visualize the simulation results, like hydrometeorology model, like more traffic simulation cases, and as well. And we do have a plan to extend our digital twins to a bigger larger spatial areas to support more urban management applications. So those are all my collaborators. Please feel free to ask questions. And Dr. Andy Barris is a specialist in data science and experts in the building modeling. If you have a question regarding the building models, I think she could help with the answers. Thank you. Please.
You mentioned automated or semi-automated.
Mm-hmm.
What is that effort really in generating it and upkeeping?
So what it does is it's basically the integration of different data sources here. And see, many of the data sources like the USGS, like LiDAR terrains, they have web services APIs. we have like a Python script paired with a GDAL, basically the geoprocessing libraries behind the QGIS to automatically gather the raster data and then generate them in the 3D. And then for the automated parts, you could also pull the building data because there are a lot of building footprint data. The OpenStreetMap also has the building outlines. You can use that to link as a primary key to link different building geometry to it, so that you could generate the spatial area of it. And another perspective would be using the fully LiDAR data, so that you download the LiDAR data through the API, and then you could also using the web map services from Google, from Esri to get their image and apply their image, basically pixel joined to the point clouds, so you got the color for individual 3D points, and then you could generate the geometry with a texture. Like a photorealistic texture, because it's the UV mapping behind the model is actually a photo rather than a shader or like a artistic made material. Please.
Does the Google Maps APIs, does that include like the 3D buildings that you see in Google Earth, or is it just imagery?
So just imageries. We tried the Google buildings, but their resolution is not very good. And as you see in the previous slides, that's basically Google Earth. And because I believe they use a combined approach from the low altitude flight photogrammetry and also the remote sensing. So everything that's under the roof is not sensed there, so it doesn't have like a details. So for driving simulation, we actually need that details.
So you're just taking their Google Earth imagery and you're just kind of wrapping it around the LiDAR?
Yes, and that actually it's a more complicated, topic. So we do define a level of details along the road. So in the remote, in the behind, you see the mountains. That's basically LiDARs wrapped, with imageries, point clouds, and then so in the vicinity, the road network is generated using Roadrunner, using professional like traffic simulation softwares, and then the surroundings are constructed like by downloading like a high resolution building data. Some of those we can model them, and some of them we purchase like the different properties or trees from the like app stores from the TurboSquid. And then we are developing a methodology basically using the land use land cover data to automate the texture generation, as well as popping out the placement of trees and the surrounding environments too.
So it looks like you have a different type of data, different data source,
Mm-hmm.
and have it of different quality.
Yes.
And maybe of different time. So how did you like merge the different type of data and select which one is good for this project?
So that's a very good question, actually. So in this presentation, I only present the visualization or the gamification part of the projects. We do have knowledge discovery engines. Basically, you could do the web spidering, web sculpting of the public source, and it has a metadata, say the USGS data, what year has it been sensed, and also the other like modeling data. You can get the metadata and can generate you interface like for you to select, and you can actually see the time and also the quality, whether it's a commercial license or public license, how you can use them.
So how do you like make a decision which one you are going to use? Just by manually or just like one by one?
For the scenario generation purposes, yes, manually, because you wanna manually like develop your simulation scenario. But for just like generating generic cities, and that could just rely on the automated pipeline, so that will reduce the manual efforts. That's why I mentioned it's a semi-automatic pipeline at this point. in future, we do envision to develop something with generative adversary networks to basically automate the modeling parts and the placements of all the entities, and also selection of the properties, 3D assets, I mean. Mm-hmm.
So like for this other vehicle, for example,
Mm-hmm.
there are other vehicles running on the road.
Yep.
What are this animation based on? Are they just generated randomly, or actually they have a real world-based data or traffic simulation?
So this is actually based off. Let me see if I can play this. Not. So those other vehicles are actually based on the Sumo simulation. So it's a co-simulation. The Sumo software exports the coordinates. Okay, I'm actually not sharing. I apologize. So other moving vehicles are generated through the Sumo, and it has a car lane changing behavior defined, car following model defined, and origin destination map defined.
So are these data actually exported to the Unity, or they stay in the
So the Unity is actually for just demonstrating our approach for generating the surrounding environments. And what we generated from the pipeline is in a 3D, like a common 3D formats like OBJ, FBX, which has animation attached to it, and also the GLB, which can also have a lighting and other particle effects attached to it. So we can import those to the Carla or to not IPG, but the Carla, like a driving simulator. So it's actually the logo behind.
Few more minutes or more? Yeah, I got one more kind of tag on to end of that. A lot of times we use VISM a little bit in our simulations,
Mm-hmm.
But then there's no collision on it. I'm guessing you guys are still not touching vehicle collisions or anything like that. You're still just relying on the simulation data
Mm-hmm.
as a kind of a read or visual only
Mm-hmm.
interaction.
So we are developing the collation parts actually. So through the Cave Lab, I can refer you to our transportation modelers at the Oak Ridge National Lab, so that basically the cave environments can recognize the coordinates. And for example, in the VISM simulation, one of the VISM scenarios, they could translate the co-simulation, basically the driver's coordinates into the VISM coordinates, and then treat it as another VISM, agent-based simulated car, so that you can simulate the collisions, and you can also, the other agents will respond to your driver-controlled, I would say, simulated car. So
Program on the back end in Unity then?
it's not Unity, it's VISM actually. VISM is the actual traffic simulation software. It does simple visualization. It doesn't do a realistic visualization, but
the collision itself, is that also in VISM?
so yes.
Yeah, that would be good. What I've seen so far did not take that into account for the driving, but
Mm-hmm.
It is something that they're working on.
Yes. Mm-hmm.
But yeah, the web-based interface does not have collision,
Mm-hmm.
and it doesn't have that nice, it's really hard to control the car. So if you saw the little police car and drive onto
It's like a drunk.
that's because it's really difficult to steer that thing.
Thank you very much.
Thank you. We appreciate.
Well, thank you all for attending. I think we had some very, very interesting, diverse set of presentations here, and you could see the opportunities that we have with visualization and with a variety of. Geez, I can't even remember all the names that were thrown out here with possibilities to do things, which I guess is a bad thing, but also is a good thing because there are opportunities to do things. So I think that the main message that I get from this is that there's a lot of complexity in getting the data to put the models together, but once they're together, then nowadays there's lots of technologies that be able to explore those, whether in VR or not, but create enough interaction to allow us to make some decisions on what we see and understand what the lesson of the story is. So thank you very much, and keep visualizing.